My topic today is web security. A really rough topic. By the end of the day, I know everyone is a little bit tired already, so I'm not going into incredible complex technical details, and I even don't have to, because did you know that Angular has already some built-in features? Angular got you already covered, and that's what I like to share with you. But first of all, when we talk about web security, like common attacks, like shipping all this JavaScript code in the front end, which, let's say, attack comes into your mind the first? Just scream it out, like one attack. XSS, perfect. Cross-site scripting, we love cross-site scripting. But nowadays we're thinking, is XSS actually still a thing in Angular? I mean, we have something that's called sanitization, right, in Angular. That basically means whenever we try to bind something malicious, bad, thingy thing to a template, Angular detects it, says, no, this is an error callback. So let's pretend this image doesn't exist actually, so the on-error callback would actually be executed, and that's how you usually can place an XSS attack in a web browser. But the sanitization logic says, well, no, we just remove it, and then Angular binds it to the template. And by the way, no other framework is doing that but Angular, which is already really, really great. Okay, so far so good. So, of course, apparently, the question is it still a thing in Angular? And if we look at some stats like CVEs, common vulnerability exposures, we see, well, we don't know, but there's still an increasing of XSS. When we see it's from CVE, you don't see the link right now, but it's on the left bottom, so you can check it out later. I also have some comparison to other common attacks like cross-site request forgery and SQL injection, and we see XSS is increasing. How can that happen? This is really incredible. But if you don't believe the CVE stats, let's go over to some top 10 lists of that are reported from pen testing and bug bounty programs. If you're not familiar with bug bounty programs, it's basically like enterprise companies giving money to white hat hackers, like good hackers, not the bad one, and they're giving them money if they find some vulnerability. And what we see here is that, surprisingly, XSS is still like on the top 3, and for bug bounty even on the first place. So the real question I like to answer today is, how can we make XSS being less a thing and even less a thing in Angular? But before that, I'd like to introduce myself a little bit. I mean, I had already a great introduction, and by the way, for me, the MCs are doing today a great job, so thank you for both of them. It's really amazing. But you're still not able to drink beer as much as I am, but all good. So I'm a consultant, I'm a trainer, I'm running workshops, I'm helping developers to make the code more secure. As mentioned, I'm also writing a book in identity management, basically. For that, since I like to hear myself talking a lot, I also got awarded as a GDE in Angular, and lately there popped up a new category, which is identity. I'm also co-organizing the largest conference in Germany, Angular conference. It's the only one in Germany, but still it's the largest one. So that's fine. You can send me an email, ping me on Blue Sky, whatnot, if you have any questions. I tend to answer questions on emails without immediately sending an invoice afterwards, so just ping me anytime. But enough for me. I heard that there's like a cool thing about icebreaker, so if you need an icebreaker to talk to me with my cats. So yes, I'm apparently also a cat lady. It's Raupi and Lenny, really beautiful, so I can talk about them for hours. But enough about me, enough about my cats. I'm pretty sure they're watching right now the live stream, so hello, my dear cats. What is the most dangerous thing when it comes to cross-site scripting? It's inner HTML, right? It's something that we bind immediately to the template without sanitization or some user input. We learned today that we hate forms, and in security we also hate forms or anything that we type into that can be immediately rendered to the template. And this is, of course, already the point where Angular actually sanitized this for us, but we need to use the Angular API, right? It's JavaScript. Nothing keeps us apart from document get element by ID dot inner HTML. It's JavaScript. And it's even more worse that some consultants and some people are actually suggesting that. Why? Because it's better of performance. When we had Zone.js and the change detection, the first solution was always injecting the change detector ref and call detect changes. When the model is out of sync of the template, that you just run another change detection again and again. And the second advice was sometimes, just update the HTML on your own, just call inner HTML. What could go wrong? Well, it's less performance. Definitely, you completely destroy everything Angular does for you. And spoiler, it's also less secure because unfortunately, now we can inject easy HTML like JavaScript code. But of course, another thing as well, and shortly demonstrate it, I have an Angular application. Yes, it's of course all about cats. It's an app called Kittygram. It's like Instagram, but you're only allowed to upload cats because cats are the best. So, and enough from cats today, I'm sorry. So, of course, we have a global search field. Global search field are like the attack vendor, what hackers like. So yes, we can search here for meow. Yes, we get a lot of meow cats. But what we also like to do, or what we also see is that whatever I type into this input field gets immediately rendered here in HTML, and you can see it, you can't see it now properly, but it's also a query parameter. So if I try to do it with a malicious, bad HTML stringy thingy thing, I can choose of many things. We have iframes. Oh, I love iframes. Iframes are also always good in security. We love that. Of course, the image example we had, but also injecting maybe an SVG. And as soon as the SVG gets loaded, bam, we execute JavaScript. So let's choose one of those three. I always love to go with the iframe example. We put it here inside. And of course, bam, the XSS attack takes place. Of course, it's in my browser, but well, since it is also inside the query parameter, I can send a link to any one of you. I mean, apparently you would now say, yeah, Martina, but if I see some strange thingy things in the query parameter, I would never ever click on it. But the cool thing is we have these QR codes everywhere, right? So you all scanned without thinking, so many QR codes today, without maybe actually checking what kind of URL lies behind it. And this is usual behavior because why should Katharina or anyone put some bad QR code in her slides, right? But now she could have maybe steal all your tokens, steal anything from your browser, what is maybe stored there. I mean, I should not get started about storing access token in a local storage. This is for another talk. But this is basically how an easy XSS attack could happen. So coming maybe a little bit to the mitigation strategy. I mean, I showed right now an Angular application. And I also talked about that these things are not happening in Angular because Angular does sanitization for us. Of course, I didn't use inner HTML, but what I used is another function which is so beautiful. It's called bypass security trust HTML. Whoever called this function, it's not bad to do that. Whoever called this function, yes, there are always a few. But just a little spoiler alert, bypass security usually doesn't mean anything good. Means be caution, be aware that something could happen actually over there. And you would need to sanitize whatever goes inside here on your own. You basically tell Angular, trust me, I know what I'm doing, don't sanitize this for me, I do this on my own and whatnot. And there are valid use cases where you might need to want to opt out from the Angular sanitizer. But be cautioned, be aware what happened. I mean, the thing is, no one of us does that, right? No, we are not doing bad things like that. But you usually don't control the whole code. We heard so many things about AI today. And the experience I made is like when, of course, you telling AI to generate code, AI usually don't care about security. AI just generates something. You would need to insert the context, would need to tell basically the AI, don't use inner HTML, don't use this bypass trust HTML function, all good, but you need to tell the AI that. And if you don't know what could happen and what bad functions are there, you can't tell the AI what to not use. So it's like an unknown problem, right? It's like what usually is called black swan. You don't know the things you don't know, right? Of course, as well, constantly following this kind of cross-site scripting guidelines is really difficult, especially if you have like a huge enterprise application out there. And like with a lot of micro frontends and whatnot, it's hard to really like dig into, yes, everything fine? Is there maybe some inner HTML call and whatnot? Luckily, and now we're talking about some mitigation strategy, luckily the browsers are supporting us a bit with that. For instance, there is an HTTP security header. It's called Content Security Policy. Who ever heard of this header? Yes, I see many hands. This is great. If you haven't heard of it, I just explain it in a nutshell shortly, because I want to go actually deeper in another step over here. But what is CSP? CSP basically means I can set up a rule set like, hey, dear browser, here's my index HTML, and if this index HTML loads some JavaScript, you are only allowed to execute this JavaScript if it's not inline JavaScript and just coming from our own origin. But it's not only restricted or limited to JavaScript, since it's called Content Security Policy. What you also could do is basically telling, yeah, if you load images, it has to be over HTTPS. It's basically also a good replacement for the X-frame options header, like this rendering in iframe in your website, no, that you are allowed to be rendered in an iframe, basically because the X-frame options header is now deprecated. Now I'm losing myself again into details, I'm sorry. But it's so basically you can control the content that is loaded and executed in your index HTML. There are two modes. Because sometimes it's really hard to apply the CSP immediately in your enterprise application, since you could block some things, because if there's something that violates the CSP, the browser blocks it. And even Internet Explorer implements CSP. Not the whole feature set, but even the Internet Explorer does some work together with the CSP, so there's no excuse of not using CSP. But of course, as I said, in usual enterprise application, a lot of code and whatnot, you're not aware of all the things that you might need to whitelist with the CSP. So you can add a report-only mode. It's not a protection against XSS or other attacks. It's more like you get a report to an URL that you also need to provide in this kind of HTTP security header. This is great. We loved it. So you should, if you never have heard of it, you should definitely dig into that. But even better, in Angular version 9, we got something really incredible. We can add this security property into our Angular JSON in some kind of our build configuration. It's called AutoCSP true, and whenever I build my Angular application, I get a default CSP insert in a meta tag. That's how you also can add CSPs to your Angular application. And this basically, I'm not going into like explaining everything that's now out there, but basically Angular brings already to you some default CSP, which I definitely strongly recommend. If you're starting a new Angular application, there's nothing that should keep you apart from just enabling AutoCSP, because it really helps us. Okay, so far so good. Are we safe? We aren't really safe yet, because what about our beloved NPM packages? They're coming from our own origin, right? So they are compiled or transpiled, however you want to call it. They are tree shake, but in the end, our CDN or our server is delivering out this JavaScript bundle, which includes the NPM packages. So a CSP that we heard till now doesn't really help us, right? And I don't know if you're following a little bit what's going around lately, but there has been some things around lately, the last couple of days. Huge NPM a lot of NPM packages got compromised. Some people are talking about the largest NPM compromise in the whole history. So yes, we might be doomed because a lot of XSS, like malicious JavaScript code, could now got injected into those NPM packages. And CSP doesn't help us currently from this. And it's not only if an NPM package got compromised, it's completely usual and normal that you maybe have a typo when you install an NPM package, right? And there exist so many packages that has a typo in it. Like when you want to install our beloved CDK, like Material CDK, there are so many packages out there with maybe called Material CKD, because you maybe had a typo into it, and you won't recognize if you install it, you won't recognize that you did a typo because it's installed, right? And bam, you have maybe another malicious NPM package. I mean, it's such an automation in our head when we type npm install Angular anything, or npm install Material or CDK. It's completely usual that we don't really look at what we're typing sometimes because we typed it already so many times. So be aware, this is actually, it's called typo spotting. It's actually also a real attack that takes place. But, and plus, of course, another stat, like according to NPM, 97% of our application code comes actually out of third-party dependencies. I'm pretty sure everyone knows would disagree, and no, I write so many code on my own. I try to avoid third-party libraries, but if you just open the node modules folder, you know exactly what I'm talking about. As well, when you type npm install, yes, there's always this kind of joke, then you can get away and get a coffee or whatnot. It might take a while to install all those dependencies. So yes, it's a real issue. But the real problem actually is that we whitelisting these NPM packages in our CSP, like that we're telling, okay, they are coming from our own origin, so please browser, let this JavaScript code be executed. Luckily, there is now a different approach. This is like kind of bleeding edge. I mean, this concept exists already out there, but it's like really new kind of thing. And it took a completely different approach. It said, okay, what is actually the issue? The issue is an assignment to some what's now called dangerous things. This is, for me as a German, really hard to pronounce, things, because we Germans, you know, we have always issues with the TH thingy thing. I'm really sorry for that. So I mean things, when I say things, I mean this things now. I call it a dangerous API. That makes maybe more sense. So what are dangerous things? Of course, all these kind of like inner HTML, there's document.write, document write line. Eval is the best, of course, as we know. And of course, like calling any source attribute in our script element or iframe or whatnot. We actually categorize them a little bit further, like regarding the security context, if it's like HTML-based or script-based security context. Like Angular also, if you maybe know, has this kind of security context. It's here the same. But again, too much detail, it's not important right now. So what basically the approach now is to say, hey, let's just protect the user from using these dangerous things. And that is basically what trusted types are doing. Trusted types are telling, hey, whenever you want to assign something into this dangerous API, like inner HTML, this has to be a trusted type now. Depending on the security context, is a trusted HTML or a trusted script. And if it's not either one of those types, the browser will reject it. The browser will say, okay, sorry, this is not a trusted type, I will not render it and I will not execute it. Of course, for that, you would need to tell the browser, please enforce trusted types. We will see that in a bit, how that can be done. And the cool thing is, regardless if an NPM package is now using a dangerous API or we in our application code, the browser will not assign it if it's not a trusted type. So we are responsible then, of course, actually evaluating and transforming this to a trusted type. So as I said, when a trusted type is enforced, the browser rejects everything. So we need to explicitly tell the browser how to convert strings to a trusted type. And basically enforcing the browser to use trusted type, we do that also in the CSP security header with something that's called require trusted type for script. And this is quite easy, so let's shortly see it. Basically, here in our index HTML, I tell now my Chrome browser, yes, please enforce these trusted types. So if I now would try again to have this attack placed, the browser says, no, 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 this has to be a trusted script, a trusted type, basically, so you're not allowed to have this executed. Okay, this is great, maybe. But how do we create trusted types now? I mean, this is kind of cool, and if we are, I mean, we would not need to do anything if we are sure that we and the NPM package are never using any assignment to inner HTML or whatnot. But if there is an NPM package and we need to use this NPM package and whatnot, we would need to tell the browser what to do then with the string, that the browser can transform this string to a trusted type and then assign it basically to this inner HTML. So we create something that's called a trusted type policy. This is part of a public API. It's almost in every browser already available. We as a developer, we define those policy basically, and only this policy then is allowed to create these trusted types. So in this policy, you have a function, for instance, create HTML or create script or create script URL, depending on security context. And then, of course, you would need to implement a sanitization logic. Of course, just marking, yes, this is now a trusted type, doesn't help us. We tell, like, yeah, how to sanitize this, sanitize it, basically. Yes, you need to sanitize it. So you need to be able to know exactly how to convert those strings to safe strings, and then the create HTML function immediately returns this as a trusted type. And the browser, either you can call this create HTML function on your own, or for some policies, the browser does it even for you. And whenever now somewhere there is an inner HTML, you can just call this create HTML function, which is pretty cool. The last part is like, okay, if this script can create now a trusted type, I as an hacker can also create a trusted type, right? I can just add another policy, let's call it meow meow policy or something like that. And then I just use it as well, and I return trusted HTML, and the browser is happy again. But of course, you can just restrict in your content security policy which policy to use. For instance, I called it my policy, so I add some line over here, trusted type my policy, and everything is fine again. Because only this policy now, really just this policy, is allowed to create trusted types. If anyone tries to inject something afterwards to add a policy or whatnot, the browser says, nope, not at all. Your policy is not registered over here. In either ways, you try to inject JavaScript code, and you can't because it completely violates everything what I'm enforcing right now. So this actually really promises to kill XSS for almost 100%. Why I always put this 100% is that you can't kill XSS 100% because there are so many different browser versions. Every browser has to align on these dangerous things. And you know that JavaScript or anything in the browser has the issue that it tries to stay backwards compatibility forever, ever. There's still possibility to render HTML3 and whatnot. So there are so many JavaScript functions that could still actually inject HTML, which the browser implementers are not considering right now a dangerous thing, hence not forcing that this has to be a trusted type and whatnot. So it's really tricky to basically kill XSS attack completely, but trusted type is such a good step towards it. I'm pretty sure you think right now, I don't want to, why the hell? So you're telling me I should implement my own sanitization logic, and you're telling me I need to write those things on my own? No, you usually don't create these policies on your own. And no, again, Angular got you covered. Because Angular has a trusted type policy. Maybe you're not aware of, but you will find it if you follow this link. And it creates a policy already for each security context, and the sanitization is with the built-in Angular sanitizer. So all you have to do is just use this policy and force trusted type using this policy. To be completely clear, there are some more policies Angular provides. Like for instance, if you still want to call our beloved function bypass trust security, this goes actually into another Angular policy, because then you would not use the Angular sanitizer, as we remember. So there is another policy called Angular #bypass security, I guess it's called, but you also find it exactly under this URL if you want to take a closer look into that. So yes, you just use Angular trusted types and you are really almost about to kill XSS in your web browser. To sum it up a bit, why can't you bypass trusted types? As we remember, you can't create trusted types on your own because only the defined policy basically can do that. You can't create your own policy because, you can't register your own policy, is it called in a better way, because this is usually done during the app startup, let's call it a bit more concrete. As soon as the browser passes the HTML, sees in the meta tag, there is the security policy, there's a trusted type, and then it registers the policy inside there. It would be a safer way not using the meta tag, but the response header, because there's some frightening out there. But if you can get in between, like inside the web browser, but there must have been then a security leak inside the web browser, like before this parsing process, so you might be able to get to the browser's trusted type registering policy array before the HTML parser does that, then you might still be able to register your own policy. This is like blah, blah, blah. Like it has a lot of ifs and whens and whatnot. But if you want to be really 100% sure, you should use the response header, the real HTTP response header, and not this meta tag over here. Having that said, I really hope I frightened you a little bit. So you take a little bit care about which functions to use, that which basically that trusted policy is a thing. The last slide before I wrap up, browser support. Yes, Chromium-based web browsers are already supporting that. We see something here that's called Firefox. I mean, the whole right part I'm leaving complete out. I mean, EE as well. Why should we still talk about that browser? But I have a good news. Even Firefox right now is implementing trusted types. Maybe it's related that even Safari started the technical preview in March for trusted types. So maybe that's why the Mozilla teams thought, okay, let's do it as well. So you can see it right now, but in the left bottom corner, I have a link to the Bugzilla track ID for trusted types in Firefox. But if you want to use it today, there is an official polyfill that works pretty fine with trusted types. So actually, there's no excuse at all to not using trusted types. And with that, last words. Thank you so much for bearing with me at this late hour. Thank you so much. Ping me anytime. And I really hope you enjoy the rest of the conference day. Thank you.